Hi, fifth graders. Today we're going to talk all about adding and subtracting fractions. And remember, in order to add or subtract fractions, we first need to have a common denominator. That's because we need to be working with the same sized piece or the same unit in order to add or subtract them correctly. If we don't have a common denominator, we can rename our fractions by writing equivalent fractions. So let's take a look at an example. I have here 2/4 plus 2/5, and right away I can tell that I can't combine the numerators yet because my denominators are different. I'm talking about fourths pieces and fifths pieces. So those aren't the same size, they aren't the same unit, so I need to start by finding a common denominator. The first step to do that is to find the least common multiple for the two denominators I have. So remember, if I list out multiples, I always suggest starting by listing out the first 5, because usually you'll find one in common within the first 5 multiples. So my first 5 multiples of 4 are 4, 8, 12, 16, and 20. And my first 5 multiples of 5 are 5, 10, 15, 20, and 25. I can see that the number 20 appears on both lists. So this is going to be my least common multiple for the numbers 4 and 5. Next, I'm going to use that least common multiple as my new denominator and make equivalent fractions. So in other words, I'll rewrite 2/4 and 2/5, and I'll make I'll make equivalent fractions using a common denominator. So let's start with the 2/4. I know I want to turn 2/4 into an equivalent fraction made up of 20th pieces. So I need to look at the relationship between my denominators. I know when I'm using or making equivalent fractions, I'm either multiplying or dividing. So I can tell that in order to turn a denominator of 4 into a denominator of 20, I need to multiply by 5. So since I multiplied my denominator by 5, I also need to multiply my numerator by 5. That means 2 times 5 is 10, or 2/4 is exactly the same as 10/20. Now with 2/5, I need to again turn it into an equivalent fraction with a common denominator of 20. So the relationship between my denominators tells me that I need to multiply 5 times 4 in order to get 20. Since I multiplied my denominator by 4, I need to multiply my numerator by 4. 2 times 4 is 8, so that tells me that 2/5 is the same as 8/20. Remember, the big idea here is that whatever you do to the bottom, you must do to the top. So now that I have my equivalent fractions, I can simply add or subtract the numerators. So 10/20 plus 8/20 is equal to 18/20. Finally, the last step is we need to look at our sum or our difference and decide if we need to simplify our fraction. I know that 18 and 20 can both be divided by 2. So if I divide 18 by 2, I get 9, and 20 by 2, I get 10, which tells me that in simplest form, 18/20 could also be written as 9/10. Let's take a look at a couple more examples together. Okay, so let's do a couple more examples, and first I want to start with some subtraction examples. So I have 1/2 minus 1/7. I know that I can't subtract these because I don't have a common denominator or a common unit. So I'll list out my multiples of 2 and 7. So 2, 4, 6, 8, 10, 7, 14, 21, 28, 35. So far I don't have anything in common on my list, but if I keep extending my 2, 12, 14, I see a common multiple of 14. So now I'll rewrite my fractions vertically. So I have 1/2 minus 1/7, and I will turn those into equivalent fractions with a denominator of 14. Actually, I'm just going to shift this one down really quickly. 7 plus 1/3. Okay, so now I need to make my equivalent fractions. So 2 times 7 was 14, so 1 times 7 gives me my equivalent numerator of 7. And I can tell that 7/14 is a half because 7 is exactly half of 14, so that makes sense that that is equivalent. And then I'm going to subtract 1/7. So 7 times 2 was 14. So I need to do 1 times 2 equals 2, which gives me a final difference of 5/14. And I can check for simplest form. 5 and 14 don't share any factors in common, so I know that 5/14 is my final answer. Okay, let's take a look at 7/10 minus 1/2. So again, if I list out my multiples of 10, 10, 20, 30, 40, 50, and 2, 2, 4, 6, 8, 10, I see that the number 10 is on both lists. So I'm going to rewrite those numbers vertically. So I'll have 7/10 minus 1/2. My common multiple or my common denominator is going to be 10. So in this particular example, I don't have to change anything with my first fraction. That's going to stay 7/10. Then 2 times 5 was 10. So I need to multiply 1 times 5 to get a numerator of 5. So now I can subtract 7/10 minus 5/10. That gives me a difference of 2/10. Now 2/10 I can put in simplest form by dividing both the 2 and the 10 by 2 because I recognize they share a common factor of 2. 2 divided by 2 is 1, 10 divided by 2 is 5, and I can prove that my answer of 2/10 is equal to 1/5 by lining up those fraction tiles. So with subtraction, I'm doing the same thing that I did with addition. I just get my equivalent fractions once I found my common denominator, and then I can subtract the two amounts. Let's take a look at one more addition question, because we're going to find that sometimes when we add, our sum is an improper fraction, and we're going to need to turn it into a mixed number. So let's look at how we'll do that. So I have 7/8 and 1/3. Again, I'll line up my numbers vertically, and I like doing this vertically because it allows me to draw those arrows and make those equivalent fractions. I know I need equivalent fractions because my denominators, 8 and 3, are not the same unit, they're not the same number. So if I list out my multiples of 8 and 3, I have 8, 16, 24, 32, and 40, and 3, 6, 9, 12, 15. I don't share any common multiples in the first 5, but I'm going to keep going with 3 until I find one that matches. My next multiple is 18, then 21. I still don't have a common match yet. Finally, 24. Now you might have recognized that multiple already, but if you didn't, this list will eventually find you a common multiple. So now I need to turn my fractions into equivalent fractions with a denominator of 24. Since 8 times 3 is 24, I also have to multiply 7 times 3, which is 21. And since 3 times 8 is 24, I also have to multiply 1 times 8, or 8. Now I can combine those two amounts together because I have a common denominator of 24. 21 plus 8 is 29 24ths. Here's where we have our improper fraction. Since 29 is greater than 24, I know that this fraction represents more than one whole. So remember, to turn an improper fraction into a mixed number, I take my numerator and divide it by my denominator. 29 divided by 24 gives me one full group and 5 extra leftover pieces. Those 5 pieces are all 24ths pieces. So I know that 29 24ths is the same as 1 and 5 24ths. So when you're adding or subtracting fractions, make sure to find your common denominators and your equivalent fractions, and be on the lookout for sums that are an improper fraction. When you find that, turn them into that mixed number answer. Thanks for watching, and I hope this helped refresh your memory on adding and subtracting fractions.